The diseases that damage the mulberry garden are leaf spot, leaf rust, powdery mildew, root knot, and root rot. The final result of this would be non-availability of healthy leaves for silkworm rearing, leading to a pathetic end of sericulture practice.
Mulberry is cultivated for its leaves to rear silkworms. This foliage is susceptible to a number of diseases, resulting directly in reduced leaf yield and indirectly affecting the growth of silkworm, cocoon yield and quality. Major diseases which affect leaf production are leaf spot, powdery mildew and leaf rust. All three are caused by fungi, and infection is therefore more likely during the rainy and winter months. The symptoms of leaf spot appear as brownish irregular spots on leaves. Spots later spread to damage large area of leaf, resulting in leaf yellowing and early falling. Leaf yield is reduced 10 to 12%. A further 20 to 25% is lost indirectly, even by the partially infected leaves. Nutritional value of the leaves is also affected through reduction of moisture, proteins, sugars and vitamins. The disease is caused by fungus Cercospora maricola and spreads through wind from sources like infected plants and crop debris. When conidia or spores fall on the leaf surface, they germinate and produce mycelia, penetrating into the leaf tissue and cause the disease symptoms in 10 to 12 days. They are capable of producing spores in another 3 to 4 days, which in turn spread the disease through wind or rain splashes. Wider spacing between plants reduces humidity and minimizes the spread of infection. As soon as the disease is observed, affected leaves must be plucked and burned. A 0.2% solution of Bavistin should be sprayed twice with a 15-day interval. The safe period to utilize leaf for silkworm rearing is 6 days after the spray. Powdery mildew is another foliar disease of mulberry, of common occurrence in high rainfall and hilly areas and in plains in winter. This disease is caused by fungus Phylactinia corelia, an ectoparasite driving its nutrients through specialized mycelia through stomata and striking the lower surface of leaf. They reproduce sexually by means of conidia in the initial stages and asexually by means of ascospores in the later stages. Plants attacked by powdery mildew show irregular white powdery patches on the lower surface of infected leaves. The patches spread and later turn black. The affected leaves become yellow and coarse. If the powdery mildew attack is not checked, it causes 10 to 15% loss in leaf yield in hilly areas and 5 to 6% in the plains. The disease can be controlled through fungicide application. Carotene or Bavistin at 0.2% concentration must be sprayed, taking care to thoroughly drench the lower surface of all leaves. For severe infections, a second spray can be given 15 days later. Leaves can be used for silkworm feeding after a week of spray. Leaf rust is yet another foliar disease occurring during winter season. Medium to coarse leaves are affected and the disease becomes severe if leaf harvest is delayed. Small brown dots appear on the lower surface of leaves and are later seen on both sides. The leaves become yellow, dry and fall off. Leaf rust is caused by Cerotelium physae and is spread through spores. The leaf loss due to this disease is around 5 to 15%. Diseased leaves lying on the ground cause the disease to spread. so they must be collected and burnt. A 0.2% solution of Kavach sprayed twice with an interval of 15 days is effective. Harvesting can be done after a further 7 days for rearing purposes. As you have seen, it is important to keep your plantations healthy. What is needed is strict vigilance and prompt action. To control root knot disease, it is necessary to attack the nematode at all stages of its growth, that is eggs, larvae and adult. Different approaches must therefore be used in an integrated manner, and control measures must be carried out for a minimum of 2 consecutive years. Deep ploughing or digging during summer exposes the eggs and larvae to direct sunlight, killing them through desiccation. Field sanitation is very important to avoid spread of disease. Saplings showing symptoms of disease like knots or galls should not be used. Garden implements should be thoroughly washed before use. Intercropping with French marigold and with sesame at 30 centimeter distance between the rows and mulching them at flowering stage enriches the soil and helps to control the diseases through the release of alpha-tertianyl-like compound. Neem oil cake is cheap, safe and effective. 2 tons per hectare per year in 4 equal split doses should be ploughed into the soil in 4 split doses at the time of chemical fertilizer application. Nematicides are expensive but reliable and therefore worthwhile in the long term. 40 kgs per hectare per year of Furadon 3G or 30 kgs per hectare per year of Rugby in 4 split doses should be used. These can be ploughed in together with fertilizer followed by regular irrigation. The safe period to utilize leaf for silkworm rearing of above nematicides is 40 to 45 days. Cost of neem oil cake application per year is 5,000 rupees and the cost of Furadon is 2,800 rupees per hectare. Another serious disease which attacks roots is root rot by fungus belonging to the genus Fusarium. Root rot shows as sudden withering and defoliation of leaves in isolated patches in the plantation. After pruning, the plants bear small rough leaves or do not sprout at all. Affected plants can be easily pulled out from the ground. The roots showing decaying with the xylem portion brown. In severe cases, the entire root system will be rotted. The infection has been found to spread through soil, tools and runoff irrigation. Excess moisture and poor drainage increase the damage. The first step to be taken is therefore prior to planting. The soil should be aerated by deep ploughing and exposed to sunlight during the summer. Deep ploughing also exposes the fungal spores to heat, killing them. Saplings should be immersed in 0.2% Bavistin solution for an hour before planting. The pits for planting should be dusted with 4 to 5 grams of diethane M45. What about established plantations? At the first signs of leaf withering, the soil around the suspected plant must be drenched with Bordeaux's mixture prepared by mixing 7.9 grams of copper sulfate and equal quantity of quicklime in 1 liter of water. Seriously damaged plants must be pulled out, making sure the entire root system is removed from the soil and burnt. The soil should be exposed to sunlight for 1 or 2 weeks. With these precautions and prescribed treatments, your mulberry plantation will be free from root diseases to yield a healthy harvest. Mulberry falls prey to several insects. Important insect pests of mulberry can be broadly classified as sapsuckers and leaf eaters. The important sap-sucking pests of mulberry are mealybug, scale insect, thrips and jacid, which occur severely during summer. Mealybug, a sap-sucker, is the most serious pest of mulberry. Attack by this pest is easily detected by the presence of malformed apical shoot, flattened or thickened stem and wrinkled leaves. These symptoms are commonly known as tukra. Its attack causes both qualitative and quantitative damage. Contrary to the earlier belief, tukra is not caused by pathogen including virus. On an average, about 300 eggs are laid by a single female. The males have 4 nymphal instars while the females have 3. Life cycle is completed in about 25 days. Integrated management comprising clipping and burning of tukra affected shoot, spraying of 0.2% DDVP prepared in 0.5% soap solution, and release of ladybird beetle is effective against tukra in mulberry. The scale insect is another sap sucker. Affected shoots start drying. They are studded with brown or black scales. Swabbing the stem with an emulsion of 1 part diesel oil and 3 parts soap solution dislodges the settled scale insects. To kill all stages including egg and crawlers, a mixture of 3 insecticides, phosmate 0.03%, malathion 0.04% and 0.05% DDVP in soap solution must be used. The safe period to utilize leaves for rearing is 10 days after the spray. Thrips is another sap-sucking pest of mulberry leaves. Affected leaves show streaks or blotches which become patchy as the attack advances. Leaves mature too early and turn yellowish in color. Affected leaves are unsuitable for silkworm rearing. To control thrips, spray 0.02% DDVP twice at weekly intervals. Leaves are safe for feeding after 7 days from spraying. Jacid causes hopper burn in the leaves. This characteristic symptom shows up first as a brown, scratchy patch at the tip, followed by similar patches all along the periphery at the vein endings. These spread towards the mid-rib of the leaf. Ultimately, the leaf becomes cup-shaped and falls off. Jacid can be controlled by spraying 0.05% DDVP twice at weekly intervals. The major leaf-eating pests are Bihar hairy caterpillar, wingless grasshopper and cutworm, severely occurring after the onset of monsoon. Bihar hairy caterpillar is a voracious feeder of mulberry leaf. They feed in groups in the first 3 instars on the chlorophyll layer of the leaf. Affected leaves soon dry up, die and fall off. In the advanced instars, they feed on the entire leaf, completely denuding the branches. Larvae pupate in the soil and life cycle is completed in 48 to 50 days. Eggs are laid in groups on the underside of leaves. They also can be collected and destroyed. It is easy to identify the infestation in the early stage itself, as the veins will be exposed in the top leaves looking like net. Black litter on the lower leaf or ground is a sure sign of presence of these insects. As the young larvae are gregarious, feeding on the underside of the leaf, they can be collected in mass effectively and destroyed. In the advanced instars, the larvae disperse widely in the plantation. At this stage, 0.2% DDVP should be sprayed to kill the caterpillar. The leaves can be fed to silkworms after 15 days from spray. Cutworms are also voracious leaf feeders of mulberry. They also affect shoots of young plant and cut them, hence the name. The grown-up caterpillars are smooth, greenish-brown in color with 4 black marks on each segment. Like Bihar hairy caterpillar, at the young instars they are also gregarious, causing similar damages. Eggs are found on the undersurface of leaves in mass of 200 to 300 in number, covered with brown scale. These caterpillars in advanced instars are nocturnal in habit. They pupate in soil and the life cycle is completed in about 35 days. Deep ploughing of mulberry garden exposes different stages where they are prone to the attack of natural predators. Spraying 0.025% parathion in the plantation kills the caterpillars. The safe period of feeding silkworm with such leaves is 8 days after spray. Deep ploughing and flood irrigation expose and kill the pupae. Wingless grasshoppers also cause widespread damage and total defoliation of the mulberry branches. They are green in color. Female lays about 6 to 8 egg pods in the loose soil at a depth of 2 to 3 centimeters, each pod containing 11 to 18 eggs. The eggs hatch in about 30 days and pass through 7 nymphal stages and complete the life cycle in about 6 months. Deep ploughing exposes the egg pods, which can be left for natural predators to destroy. Spraying 0.5% BHC on the plant is effective. The safe period is 10 days. The measures explained are effective and economical to avoid leaf and crop losses due to attack of insect pests. Remember, pest-free plants ensure better yield of quality leaves.
Silkworms are prone to a few diseases and pests. These must be combated effectively at the right time. The 4 major silkworm diseases are pebrine, flasherie, muscadine and grasserie. Of these, pebrine is the most destructive. It is a silkworm disease known to be transmitted from generation to generation through eggs. Microscopic examination to screen disease-free seed, surface disinfection of eggs, disinfection of rearing space and appliances, screening of healthy worms during rearing, and strict maintenance of hygiene are the steps to be adopted to control this disease. Flasherie, another disease, is caused by either bacteria or virus that multiply due to faulty rearing. Correct feeding, maintenance of hygiene, providing adequate rearing space and aeration are the best insurance against this disease. Grasserie is another common disease that infects silkworm, especially in the late age. The infected worm swells and a white fluid starts oozing from the body. Worms become restless and start moving around in the tray. Infected worms must be promptly picked up and destroyed. The disease can be prevented by the application of a chemical mixture applied on the silkworm body as per schedule. This helps prevent both grasserie and muscadine. Muscadine is a fungal disease that occurs during the monsoon and winter seasons when humidity is high and temperature low.
Amongst the insect pests that attack the silkworm Bombyx mori, the most formidable one is a parasitic fly commonly known as the oozy fly. This pest is a serious menace prevalent in the entire tropical sericulture region of which India is a part. Infestation is highest in the monsoon months, followed by winter, and least during the summer months. The extent of damage caused to silkworm cocoon crops ranges between 10 and 15% and is sometimes even as high as 40 to 50%. Silkworm rearers have been using physical preventive measures like wire mesh coverings over all openings and nylon net enclosures. However, these measures help only marginally, and to bring damage down below economic injury levels, a new approach called the integrated management of the oozy fly has been developed. This pest management system encompasses even chemical and biological control measures. Chemical control is a necessity for effective, immediate control of the oozy fly. These controls comprise the use of oozicide and oozy trap. Oozicide is a liquid formulation that kills the oozy eggs laid on the silkworm body before hatching. It should be sprayed through a hand sprayer on the silkworm body when it is fully exposed. Feeding should be undertaken only after half an hour of spraying. It is extremely important to ensure that oozicide spraying is done every alternate day, starting from the second day of the third instar through the late fifth instar. It should be avoided at molt. If the day of molt happens to coincide with the scheduled day of spraying, spraying may be undertaken one day earlier or on 2 consecutive days. The oozicide quantity recommended per 100 layings is 5 liters. The quantity may vary depending upon the silkworm race. Oozy Trap is another recently developed chemical formulation that traps and kills the adult oozy fly and prevents it from physically approaching the silkworms at rearing. This is available in tablet form. To prepare the Oozy Trap solution, 1 tablet must be dissolved in 1 liter of water. The solution must be stirred with a stick after 15 minutes to ensure that the chemical is uniformly distributed. Ideally, the prepared solution must be kept in a white 10-inch diameter plate or in an 8 by 10-inch tray 2 inches deep. The prepared plates or trays must be placed on the inside and outside of every window and ventilator in the rearing room. They should be hung or supported by a stool or platform at the level of the window's base. 1 plate can also be hung within the nylon net rearing enclosure. The solution need not be changed unless it becomes dirty due to dust, litter, etc. It effectively traps oozy flies and is safe both for the silkworm and the user. The Oozy Trap solution must be used constantly during late age rearing of the last 3 instars. With chemical methods, the plan for the integrated management of the oozy fly also encompasses the use of biological methods to control proliferation. A number of parasitoids are natural enemies of the oozy fly and attack it in very much the same way as it attacks the silkworm. Amongst these parasitoids, the Nisolynx thymus can be cultured and multiplied with minimal effort. The female of this parasitoid lays her eggs in the oozy pupae. On hatching, the parasitoid feeds on the host tissue and 15 to 18 days later emerges by cutting a hole through the pupa wall and killing it. Since this parasitoid does not parasitize silkworm larvae, pupae or eggs, its release in and around the rearing house is completely risk-free. 2-day-old adults are ideal for release. They should be transported within 24 hours to the rearing site in a special release container and released into the rearing room, mounted storage room, spinning site and manure pit within an hour or 2 of sunset. For maximum effect, 1 lakh adult females and 5,000 adult males must be released per every 100 layings of silkworm. The released Nisolynx thymus travels a maximum distance of 200 feet and seeks out the oozy fly pupae for egg laying. Each adult female can parasitize 4 to 5 host pupae in a lifetime. This goes a long way in reducing the oozy fly population and substantially contributes to the effective control of oozy infestation in silkworms. This integrated approach has been demonstrated in some villages of Karnataka and Tamil Nadu. About 80% suppression of oozy infestation has been observed. With this approach, the highly destructive oozy menace can be suppressed to keep infestation below economic injury levels. An additional harvest of 5 to 6 kilograms of cocoons can be ensured, and in effect, in return for just a little extra effort and cost, the silkworm rearer harvests the rich rewards that naturally accrue from a healthy cocoon crop free of oozy infestation and damage.